Hey, this is my lab video with the low pass and band pass filters. So right now on the breadboard I have the band pass set up. Basically, okay, so very messy, sorry about that. But the important part is you have your resistor that runs into a parallel connection with the capacitor and an inductor. And we have one probe here attached to just like the input power, because that's what we're measuring gain relative to, and the other is measuring across the node that contains the capacitor and inductor. Um, yeah, so we did the frequency sweep on that just to like look at the behavior and try to see if we could find the resonant frequency. And what we have is this. So you can see on top we have our gain, and on the bottom we have our phase response. So the gain at one point approaches zero. So that's essentially when all of the voltage in the circuit is being dropped across the capacitor and the inductor. So that basically means their impedance is collectively at a maximum, so very little of the voltage is being dropped through the resistor. And the phase response in this case, at zero, when the phase response is zero, that's when you get to your resonant frequency. Um, it can also be sort of useful to look at it as like a combination of two filters. So like your phase response is basically just like the addition of those two. So when they get to zero, that's when it's in resonance. That's when your filter is at the resonant frequency. And we got like 87, 86, 87K or so, which was pretty close to the value we predicted. Okay, so the other circuit we did was just remove the inductor. You only have the capacitor, and now that is your low pass filter, which I believe we also did last time. So let me bring up our waveforms for that. So yeah, you see the -3 decibel drop off appears to be at like, well, it's hard to tell with this scale, but probably around like 80, 89, 90 kHz. So yeah, let me just look at the lab report